Now we're going to talk about the mean squared error, and if you remember, this is what goes on the bottom of the F statistic. So we have MS between the time points on top and the MS error on the bottom. So we need to find the MS error as well, and the mean squared error is the sum of squares error divided by the degrees of freedom error. But to get the sum of squares error, you need to actually do it a little bit differently than you're used to. So the error is what isn't explained in your model. So if you take the sum of squares within and subtract the sum of squares subjects, you'll get the sum of squares error. So sum of squares is just the total variability. So we take the total variability within each time point minus the total variability accounted for by the subjects to get the sum of squares error. So remember you're deleting the individual differences. So that would be here, and we're going to subtract it out, and so we're trying to get rid of it, basically. So what you're left with for the sum of squares error is the total variability within the time points that's not explained by individual differences or by having a score from a certain subject. Okay? And then we have the degrees of freedom error, which is the number of time points minus 1 times the number of subjects minus 1. So we're going to do an example here. So to get the sum of squares within, you kind of do the usual thing. You're going to find the sum of squares within by adding up all the sum of squares. So we're going to have the sum of squares 1 for time point 1. So you're going to have the sample mean for time point 1, and then you're going to get the deviations for those scores, then square those scores and add them up to get the sum of squares for time point 1. And then you're going to do it separately again for time point 2. And lastly, you're going to do it again for time point 3. And in this case, it's 8 plus 19 plus 8, which equals 35. Now you need to find the sum of squares subjects, and this is similar to the sum of squares between time points, but instead of doing it between the different time points, we're doing it between the subjects. So we're seeing how much of the variability is accounted for by the subjects, by the individual differences. So the first thing you need to do is find the sample means for each subject. So take each subject and get their observations and find their sample mean. And I have them listed here for us. And then you want to find the deviations from the grand mean, and the grand mean is 9.5. If you remember that from before, you can get the grand mean again by adding up all the observations. In this case, there's 12 observations. Or adding it all up and dividing by the sample size, or you can take the sample means and divide by the number of sample means if the number of observations per sample mean is all equal. And so in this case, we don't have any missing data, so each subject has 3 observations for each of the 3 time points. So in this case, we have equal sample sizes for each sample mean. So you could add all the sample means up and divide by 4 to get the 9.5 if you forgot what it was from the sum of squares between time points. But anyways, you take the sample mean and you subtract the grand mean. And so we have 7.3 9.33 minus 9.5, then 9.33 minus 9.5, 12 minus 9.5, and 9.33 minus 9.5. Then you want to square each of those deviations. So you have negative 2.17 squared, negative 0.17 squared, 2.5 squared, and negative 0.17 squared again. And then in the last column, you want to take the number of time points for each subject. In this case, it's 3 for each of the subjects because each of the subjects were in the data set 3 times. There was no missing data. And you want to take the number of time points times your squares from the previous column. In this case, we're multiplying by the number of time points because we're getting the sum of squares for the subjects. Before, when we're getting the sum of squares between, we multiplied it by the number of subjects. So now it's in the reverse. And again, the reason we're doing that is because we really want to do this for each of the observations, but it would get repetitive. So instead of doing it 3 times, say for all the observations in subject 1, then we just multiply it by 3 because there's 3 observations for time point 1. Okay, so we take 3 times 4.71, 3 times 0.02, 3 times 6.25, and 3 times 0.02. And we have those answers there. Then you want to add them all up to get the sum of square subjects. And if you add all of those up, it equals 33. So if you have the sum of squares within and the sum of squares subjects, you can get the sum of squares error. So we had 35 for the sum of squares within, 33 for sum of squares subjects, and if you take the difference of those two, it's 2. And so that's the sum of squares error. Now we also need the degrees of freedom for the error, and it's the number of time points minus 1, which is 3 minus 1, which equals 2. And then the number of subjects minus 1, and that's 4 minus 1, so that's 3. So we have 2 times 3, which is 6. So the degrees of freedom error is 6. Now that we have the sum of squares error and the degrees of freedom error, we can find the mean squared error. So we have the sum of squares error, which is 2, divided by the degrees of freedom error, which is 6, and that gives us about 0.33. And that will be the bottom of our F statistic.